An ideal gas at pressure 2.5 into 10 to the power 5 pascals and temperature 300 Kelvin occupies 100 cc. It is adiabatically compressed to half of its original volume. Calculate the final pressure, final temperature and the work done during the process. So first of all I had to calculate the final pressure. Now the process is adiabatic, so clearly PV to the power gamma will be a constant. This is the condition for adiabatic. So I do have the, let's say initial pressure is P1 and volume is 1, so I can write it as this. Alright, so initial pressure is given to me as 2.5 into 10 to the power 5. Initial volume is also given, that is 100 cc. Let it be in cc only, I mean centimeter cube only, because there is no sense of converting it into meter cube, because I do have the volume again over here. So no matter what, it will be a ratio of V1 to that of V2. So no matter what is the unit of V1 and V2, it both get cancelled. So let's say V1 is 100 centimeter cube and V2 is half of its original volume, that is 100 by 2, again 1.5. So it comes out to be 2.5 into 10 to the power 5 into 2 to the power 1.5. That is my final pressure. Just solve this and you'll get the value of final pressure as 7.1 into 10 to the power 5 pascals. In second case, we have to calculate the final temperature. Now as I told you, PV to the power gamma is a constant value and we know that it is an ideal gas, so PV is equal to RT. So just replace pressure by RT by V, alright, over here. So I get T into V to the power gamma minus 1 as a constant value now. So I can write T1 V1 gamma minus 1 is equal to T2 V2 gamma minus 1. So I have initial temperature as 300, volume as again 100 into 0.5 into T2 that I have to calculate into 100 by 2 gamma minus 1. So 300 into 2 to the power 0.5 is equal to my final temperature. It gives me the final temperature as 425 Kelvin. In the third case, that is, we have to calculate the work done. Now since it is an adiabatic process, so change in heat will be 0. So work done will be equal to minus of change in internal energy, that is given by minus of NCV delta T. So CV is given as R by gamma minus 1. So N into R by gamma minus 1, and it will be minus delta T, so it can be written as initial temperature minus final temperature. So I'll substitute the values. So the value of N can be calculated by the earlier equation, because we'll use PV is equal to nRT. I know the pressure, I know the temperature, I know the volume. So N comes out to be P1 V1 by RT1. It can be written as P1 V1 by RT1 into R by gamma minus 1 into T1 minus T2. Substitute all the values. Pressure as 2.5 into 10 to the power 5. Volume is 100 centimeter cube. That is 100 into 10 to the power minus 6 by T1, that is 300 into gamma minus 1, because R is cancelled. So that is 0.5 into initial temperature, that is 300, and the value of T2, that is 425. So solve this, you'll get the value of work done as 21 joules, and that is of course with a negative sign. The negative sign simply shows that work is done on the system.